Hello dear friends, welcome back to my channel. I'm Gerard and I'm here to study differentiation. So differentiation, uh, I have done a lot of videos in this series, and right now I would like to review the basic rules for differentiation. The basic rules for differentiation. So we have heard about the power rule, the product rule, the quotient rule. We haven't covered the product rule and the quotient rule. The chain rule, of course, we use it. The sum rule or the difference rule, these are things that we certainly use. So we're going to review one by one, and so let's start with the constant. So there's something called the constant rule. The constant rule, that's when you are differentiating a constant. Let's say you have an equation y is equal to 3. Y is equal to 3 is just a parallel line to the x-axis. This is y is equal to 3. Okay, so which means that it does not have any gradient. It doesn't have any gradient. It's flat. It's horizontal. So dy by dx is 0. If we had like y is equal to x, okay, so if we differentiate dy by dx, we'll get 1, right? Because here is the power of 1, we times here, and we have x to the power of 0, which is 1. So 1 times 1 is equal to 1. So this is a constant rule. When you have a constant, it means that it does not change. A constant does not change. Alright, this is for the constant rule. Now we have a constant multiple rule. Have the constant multiple. A multiple, just a constant, bumping up the number if you want. Let's say we have um, y is equal to 3x this time. So if we want to differentiate this, yeah, we can put the 3 outside. We can put the 3 outside, yeah, and then we differentiate we differentiate x, so which is 1, and then we say that it's just 3. So basically we don't have to differentiate constant if there is something else with them. If we have a variable and there's a constant with it, we can just ignore it. We can like put fx here. Let's say that we have this, we just write it like that, y is equal to 3fx, and then we can dy by dx is equal to 3 times f times x is going to be 3. So that's something like, usually it does not bother me to leave it here, but there is this kind of rule. If you want to learn it, you can learn it. I didn't learn this. It's just natural. Product rule, the power rule, sorry. This is the most important because you find it a lot of time. You have, for example, y is equal to x to the power of 2. If you differentiate this, you're going to have 2x. What happens is that if you have a generic uh, equation in the form of this, you'll have a times n and minus 1. So this is with the constant. We don't put out the constant and so on. It makes things more complicated, but sometimes it might be useful if you have a crazy constant like 16, or I don't know, some crazy stuff like, I don't know, this even it's still good, but alright. So that was a power rule. Now let's just try the sum rule. Sum rule is when you have two things. Let's say we have y is equal to x squared plus 3x. So we have two things here. we cannot add them up because they have different different power. They are not the same thing. They are not at the same power. And so how are we going to differentiate this? dy by dx, we can differentiate this here, ddx here, plus d dx of 3x. So we just do 2x plus 3, and that's a general thing. So we just do term by term. Sum, we can say that it's term by term. We're differentiating term by term. Alright, so that's done. That was for the sum, and we just have the same for difference. Difference is just subtraction. Difference rule. This time we have like y is equal to x squared minus x. So we can just say dy by dx is going to be d dx x minus d dx of x. And we're just going to have 2x minus 1. And that's the dy by dx, that's the derivative. So again, we're going term by term. Easy. So nothing to remember really. So the power rule is important. The power rule is important. Now we have the product rule. This one is important as well. The others are just like sometimes just clustering. The power rule, and the product rule, these are the important ones. So here we have a product. We have, for example, y is equal to x squared times x cubed. This is a power rule. We cannot just say 2x3 times 3x 2. Sorry, 2x1. Yeah, we cannot just differentiate this like that. This is not going to be good. So there is a way to do it. So we say that this is a function. We call it fx, and this is going to be gx. You can go like this, fx, gx, or if you're using y, sometimes we say this is u. That's how I learn it actually. But it depends. This is u, this is v, because u comes first and v after it. So dy by dx is equal to, for the product, u times dv by dx plus v times du by dx. So this is the rule. U times dv by dx plus v times du by dx. In other way, you just you just take the first one here, multiply by the differentiation of the second. You take the second plus the second multiplied by the first derivation. So let's try it. I will erase this. Let's try this. We didn't do it, but now we're going to do our first product rule. dy by dx is equal to x squared times 3x2. This is the first part, plus we're going to say x times 2x. This is the second part. So what do we have? We have 3x 4. Yeah, that's correct. That's correct. Plus 2x4 here, which give us 5x to the power 4. What is interesting is that This is the answer. This is the answer. Because I took an example that could be simplified. That's why it's very easy to check. This is our answer. This is our answer. We can quickly check our answer because look, we can easily say that y is equal to this, and the y by the x is equal to 5x4, which is the same thing as this. But sometimes we cannot simplify such things because it's more complicated. Let's say it's x minus 1 to the power of 3, for example. Then it's going to be more problematic. No. But if it's just like that, we can simplify it, do it straight, a power rule, and so on. But it was a nice way to check if it works, even if we don't want to simplify it. So that was a product rule. And now we're going to do the quotient rule. Quotient rule is when we are dividing. We're dividing. So we'll have an example like just like what we had before. Let's say we cannot do this. Normally we can just say it's minus 1 here because we put this up. It's this. If we will differentiate this, it's going to be x minus 2, yes, 1. So it's going to be minus 1 over x2. This is the answer that we have, knowing that we can simplify it. But if we can't simplify it, we're going to use, remember that this is the answer for the differentiation, the dy by dx. So I hope you will remember, but let's do this. The quotient rule is just like this. dy by dx is going to be, let's call this v, let's call this u. We're going to have v times du by dx. It's not the same as the other one. The other one we had u v by dx plus. Now we inverse things because we're not dealing with product. We're dealing with quotient. Minus u times dv by dx. And that's not all. You have to put v over square, divide by v over square. So what is it going to be? I'm going to erase this because unfortunately my screen is not big enough. So I'm going to do the dy by dx. So we have x to the power 5 times the derivative, which is this, minus we have x to the power 4 times 5x to the power 4. And we have to divide by x to the power 4 cube. So what do we have here? We have we have 4x to the power of 8 minus 5x to the power of 8, which gives us minus 1, x to the power of 8, divide by x to the power of, x to the power of 10, because you multiply here. You multiply, oh, you have to add them. It becomes 7, sorry. It's not multiplying. No, here we are adding. Here we have to multiply. That's correct. That's correct. That's correct. So this becomes 10, right? So we divide by x10. If we bring it up, we will have 1 x minus minus 2. And we can rewrite it like x minus 1 x over 2. So was it the same as what we got when we just simplify it? Do you remember? Do you remember? I think it was the same, but we're just going to do x is equal to minus 1 minus x is 2 is equal to minus 1 over x 2. That's the same. The same. So quotient rule works. The quotient rule works, and we have a last, the chain rule. This is also important. Quotient rule, chain rule, product rule, power rule, these are important. The others are just like, natural things, So here, it's an easy example is y is equal to x plus 2 to the power of 2. So how do you do this? You can simplify, like this is a perfect square. You know that it's going to be like, we can already write this plus 4. We can, 2x plus 4. We have the answer, 2x plus 4. This is a derivative, dx by dx. We have this. But guys, let's say it's more complicated like this. You have something here. I have something here that is much more difficult. So what we do is we differentiate. We can call this u, for example, ux. We differentiate it, du by dx. Sorry, this is u. So dy by du is going to be 2u. And it's going to be 2u. Yeah. Let me just get things done correctly, because I understand that it might not be. Let u is equal to x plus 2. So therefore y is equal to u to the power of 2. dy by du gives you 2u. Now because we have this new equation, du by dx is going to give you 1. To get dy by du by dx, you take dy by du multiply by du by dx. This will cut, which gives you dy by dx, dy by dx. So you have to multiply 2u to this. But let's do this. Let's do this. So what we're going to do is just going to write this. 2u is 2x plus 2 multiplied by 1, which gives you x plus 2. That's it. That's the answer. So we use chain rule, and we got this. But I did it just like straightforward. 2x plus 2, 1 times 1. Straightforward. I just differentiate the first thing, the first function, and then times what's inside. But this is the chain rule. This is the chain rule. So that's it. So we did all the rules, and you can also, for example, I have a list of things here. I have an exam on it coming soon. What else? Yeah, let's do some differentiation. For example, here I have d dt t alpha. So we know it's going to be alpha x minus 1. It's something simple, but if we have d dt et, it's going to be et. It's going to be et. Don't ask me why. Probably because I don't know, differentiate an exponential, it stays the same. D dt ln t gives you 1 over t. Such things that, natural logarithm, things like that. But if you want to just revise a little bit, we did the constant d dt c is 0 because c is a constant. D dt at, this is just the power rule. Actually, because we're differentiating t here, yeah, and it's in power, so it's going to be ln a here. It's not the power rule. It's not like t to the square or ta. It's ta, it's going to be like that, t minus 1. That's not it. That's how the power. We have, you know, in respect to t, but t is a power here. So for that reason, it becomes at times ln a. This is something that a to the power of t, sorry. I made a mistake here. Or is it? Yeah, a to the power. That's not correct. Let me write it in the proper way. It's at ln a because it's like 1 over t. So if you differentiate ln a, you get 1 over ln t, you get 1 over t. Yeah. But this is the inverse. I don't know. You have to learn it. You have to learn these properties or something like that. And just to wrap up here, you have like d dt log at. So if you differentiate this, it gives you something weird like t ln a. So 1 over t ln a. But things that you will probably use is like differentiating sine t is going to give you cos t. This is something useful. Differentiating cos t gives you minus sine t. This is also useful, and I'm not going to get in the others, but these two are most useful. Alright, so that was differentiation. I think I'm ready for my exam, but unfortunately I have now to do for the second part of the exam, which is about integration. So I'm starting a new series after this one. I'm going to do everything about integration. So stay tuned. Bye.